Of everything in Module 1, sensible and latent heat are the two most important concepts that you need to understand. You should not move on to Module 2 until you really have a firm grasp and understanding of sensible and latent heat, because once you hit Module 3, if you don't get it, then you are going to you're going to be struggling in Module 3, and if you don't get it at all when you're an air conditioning technician, you're going to really struggle when it comes to refrigeration problems. So let's talk about sensible heat. Sensible heat is what we're used to experiencing in our day-to-day lives. I'll give you an example. It's on a winter day, you come home from work at 65 degrees and you turn the thermostat up to 72, and then the air starts to warm up, thermostat starts to rise. You can measure it and you can feel that warmth, and you can feel the air getting warmer, and that is an example of sensible heat. So it is heat that can be measured with a thermometer. And I also want you to remember, when we're talking about sensible heat, think about molecules in motion and not just hot to the touch and heating things up. So remember, heat is molecules in motion. Latent heat, this is the one that everyone gets hung up on. So let's talk about that just a little bit. Now, latent heat is called hidden heat, and it is the heat energy, molecules in motion, that changes the state of a substance. So, for example, and if you watch the supplementary video, there is a pot of water, and when it starts to boil, it is changing from the liquid form of water into a vapor, and the heat transfer, molecules in motion again, all of that energy is used to change the state of the water from liquid to vapor. Now, you know water boils at 212 degrees, and as long as it's boiling, it doesn't matter how much heat. You could put 5,000 degrees underneath that pan, and that water is only going to, as long as it's boiling, is only going to be 212 degrees. So that is a latent heat that is changing the state of water liquid to water vapor. Now, the thing to remember is, with latent heat, if that water vapor hits a cool window and then it condenses and it drips down your kitchen window, that is latent heat being released from the water vapor, and then it condenses that water back down into its liquid form. All right, so in this slide that comes with this lesson, it talks about three terms that are important to understand about latent heat transfer. The one thing that I want you to know is that the latent heat diffusion, we don't use that often, if at all, in HVAC. That latent heat diffusion is the heat that is released when, for example, water turns into ice. So when it fuses from a liquid to a solid form. So that's just good for you to know. But the two things you really need to know are latent heat of vaporization, and that's where we talked about the water boiling into a water vapor. Now, it doesn't necessarily have to be water, as long as we have a liquid and it's turning into a vapor. It doesn't really matter. So liquid heat of vaporization is the molecular energy that is required to change the state of a liquid to vapor. And then the latent heat of condensation, that's our water vapor that lands on the kitchen window and turns from steam back into water. All of that latent heat is released, and that's called the latent heat of condensation. All right, so here is the diagram in our book, and we're going to talk a little bit about this and explain why sensible and latent heat, especially latent heat, is an important part of air conditioning. Now, it starts out right here with water as ice, and then it melts down into water in the liquid form. We're going to start right here at, let's say, 33 degrees, just above zero, 32 degrees, just above freezing. So actually, we're going to start right here. So when we start to apply heat to the water, the water temperature starts to rise from 32 degrees and it increases up this line right here, and we can measure it with a thermometer until we hit 212 degrees. Now that is the sensible heat, and this legend down here at the bottom is the heat content in BTU, and you can see if you follow this down that it's only 180 BTU are required to heat that water. It's 1 pound of water, for example, from 32 degrees up to 212. It doesn't take a lot of molecular energy or heat to raise the temperature as far as sensible heat goes. Okay, once we get up to the point where the water begins to boil, it's changing state. So this is when we start to get into the latent heat zone, and that 1 pound of water, as it's boiling off into vapor, requires 970 BTUs of latent heat. Here we had 180 BTUs to raise the temperature, but look how much more heat energy is required to change that water from liquid to vapor. And this is key, this latent heat. Remember, this can't be measured by a thermometer. It is a change of state, transfer of energy, and it's really important that you understand this concept. Now think about this. If it didn't escape, once all of the water was boiled off into vapor, it can't change state anymore if we add heat. So what happens is that vapor goes from 212 degrees, and once again it's the sensible heat starts to rise up, and that is our sensible heat in the vapor form. So down here, let me erase this. Down here, when we're in the liquid form, we're raising the temperature. It's not changing state. Then we get to the latent heat stage. This is where it's boiling off and it's changing state all the way until it's completely vapor. And if we had it in an enclosed and captured vessel and we continued to add heat, then that steam would become superheated and it would gain more sensible heat. Really important. This part from here to here on the chart, and from this point to this point, and all the way up here into this sensible heat range, that is where we are going to talk about refrigeration in the future. So when we're down from here to here is what you really need to understand. All right. All right, so specific heat, just a definition. It's the number of BTUs that you required to raise a temperature of 1 pound of any substance 1 degree Fahrenheit. And the standard is water, so specific heat is 1 for water. And then you can look in here, they have ice, steam, and air, and it shows that it requires less BTUs to raise the heat of the temperature of ice, steam, and air than it does to raise the heat of water. So just remember that specific heat is the amount of BTUs required to raise the temperature of 1 pound of any substance 1 degree Fahrenheit.